Okay, let's do a few problems from the Module 3, Lesson 3 problem set. So this problem set is mostly about using the distributive property when we have expressions with variables in them, and also looking at these rectangular array sort of examples or diagrams that they have and how they relate to the distributive property. And then essentially using that property to get your expression written in standard form is almost always the final goal. So question 1a says, write two equivalent expressions that represent the rectangular array below. So there's two expressions that come from this array. One is we're doing 3 times the quantity 2a plus 5, because the length of this top side of the entire rectangle would be 2a plus 5. So to write that, we would write 3 times the quantity 2a plus 5. That's one expression that represents this. The other one you would get by doing the distributive property, by doing 3 times 2a. That would give you the area of this first box. And then 3 times 5, that gets you the area of this second box. And when you add those up, you get the area of the whole box, which is sort of what this expression represents. This times this is the area of the whole box. So both of them can be thought of as the area of the whole box. And one is this sort of factored form expression, and the other one is what you get in standard form when you distribute the 3n. So you get 6a plus 15. And you can fill this out in the same way too. 3 times 2a is 6a, and 3 times 5 is 15. And maybe just put your little plus sign there or whatever. It says, verify informally that the two expressions are equivalent using substitution. So what you would do is choose any value you like, a equals 5, a equals 10, a equals 2, whatever. Negative number, maybe a, well, I don't know if I'd use a negative number. Anyways, choose any number you'd like, substitute it in for a in this expression here, and then do the same thing into this expression here. You should get the same value. That's a very informal way of checking that two expressions are equivalent, because really you need to know that the expressions evaluate to the same value for any substitution you would make for a. You're just checking one number. So that's why they say it's an informal verification. Let's see here. I'm going to skip the word problem. I'll let you work with that. I will do one of these, use a rectangular array to write the products in standard form question. So they're talking about, like we did in question 1a, this box thing is a rectangular array. So if I set one of these up like this, because there's two terms within the parentheses here, the x plus 10, I'm going to split my box into two parts. This next one that I'm not going to do for you, but just to let you know, you're going to want to split your box into 3 parts for this one, since there's 3 terms in the parentheses. So what I'll do is I'll put the 2 that's outside the parentheses on the side of the box, and then I'll put one term above the first section of box, so x, and the second term above the second section of the box. Then I can multiply through. 2 times x is 2x, and 2 times 10 is 20. And so that means that the expression in standard form would be 2x plus 20. Okay, so you just do the same thing for 3b. 4 says, use the distributive property to write the products in standard form. So I'll do a couple of these for you. We're just going to distribute whatever's on the outside of the parentheses to the stuff on the inside. So 3 times 2x is 6x, and 3 times 1 is 3, and we have a minus sign, so 6x minus 3. You can distribute from both sides. Normally you wouldn't write the number you're multiplying through the terms in the parentheses on the right side like this is, but it doesn't really change anything. It's just unconventional. So I'll distribute this way. 6 times 8j is 48j. 6 times 3l is 18l, and I have a minus sign. And then 6 times 9 is 54, so plus 54. Probably would have been better if I wrote that below. Then over here, these are all division ones. Remember that division is just multiplication by the multiplicative inverse. So division follows the exact same rules as multiplication in terms of how you would distribute it through multiple terms within the parentheses, just except you're dividing instead of multiplying. You could do that by just dividing the terms. 40 divided by 10 is 4, so that's 4s. And 100t divided by 10, that's 10t. You can think of it that way. Or if you prefer, you can rewrite these as what we call in class a keep, change, flip. You could think of it as, instead of dividing by 6, you could think of it as multiplying all the terms inside the parentheses by 1/6. So I'm doing this one here. I'm changing dividing by 6 to multiplying by 1/6. I'm going to rewrite the 48p plus 24. And then 1/6 times 48, that's 8. It's the same thing as 48 divided by 6. And 1/6 times 24, that's 4, because I know that's the same thing as 24 divided by 6. So you have two options on how you can do these. You can just divide through, like I did in the first one, or you can keep, change, flip, multiply by the multiplicative inverse, I should say, like I did in the second one. And then for the last ones, they say, write the expression in standard form by expanding and collecting like terms. So when they say expanding here, what they really mean is using the distributive property. Distributing is a form of expanding because you're sort of breaking these terms outside of their parentheses. You're changing what is a product of two factors, this 4 and the quantity inside the parentheses, to terms that are being added. So I guess I'll just do this first one, and then I'll leave the other two for you. So 4 times 8m is 32m. It kind of looks like an M, or an N. It should be an M. Minus 4 times 7 is 28, so 28n. And then I have a plus sign here, so I should bring that over. Then 6 times 3n, that's 18n. And then let me draw my little arrows. You don't have to draw these arrows, I just do it to help you see what I'm doing. And then 6 times 4m, that's 24m. I've got a minus sign in front of it. And so now I can combine my like terms since everything's outside the parentheses now. I've got 32m minus 24m, so that's going to give me 8m. And then I have negative 28n, or you can think of it as minus 28n, whichever way you prefer, those are the same, plus a positive 18n. That's going to leave me with negative 10n. And you can write that as minus 10n, or you could write it as plus negative 10n. It doesn't matter, both of those are equivalent. Then I'm done, because I've got an m term and an n term. They can't be combined using addition, so I'm done. You just do the same thing with these two, and you'll be done too.